Text processing. Welcome to this lecture. In most modern programs, the thing that we worry about most is text. It just isn't. Even if you're a data scientist, you worry about text because a lot of your input will be text. And then you have to do what's called ordinalization or cardinalization to change those texts into numerical values so that your data sciencey stuff can do science on the numbers and not on the text. But we do mostly text. Text is everywhere. And that's generally what we're doing. So we're going to have to learn how to work with text a little bit. So now that we know about tuples, which are just immutable lists, they're like lists that don't change. Now we can use the metaphor that strings are just tuples of letters. They're tuples of letters. So this thing right here, this string, which contains the characters I, space, heart, space, Python, that's 5 characters long. It's like a tuple. It's like if I had a tuple of individual letters here that just, it's immutable. I can't change a list. Oh, here's a snake. Rawr, a snake. Yeah, we all drew snakes. That was fun. So this tuple of letters is really kind of like what a string is. And so we can, everything that we can do with tuples, we can do with strings too. And more, because strings are so important in programming. So for example, we can loop over each letter or each character inside a string. And then if we strip off the white space and look at its length, if that's greater than 0 and we print that out, we end up printing out the 3 characters inside here that aren't just white space. They aren't just spaces or whatever. So I, heart, Python. So we can loop over strings just like we can loop over tuples. And we can get the length of strings just like the way we get lengths of tuples. So just like with tuples, we can get the character, the letter out of it at a specific index, and the indexes work just like tuples and lists. It starts at 0 and goes all the way to the end, which is 1 less than the length of the string. So message at index 2 is right here, and that's the heart, so it would print out the heart. We can get the length of a string. Length of this message right here is 5. Now, that's something that sometimes we kind of forget. Why is the length of this 5? Because it's looking at every single thing in here, including the spaces. And that's important, including the spaces. So the length of this is 5 letters long, 5 characters long. We can concatenate, which means make a new string out of 2 other strings. So we can take our message and add an exclamation mark onto it. So now we've got I, heart, Python, exclamation mark, and that string is inside exclaim. Message is still the original message, and now exclaim has that string and the exclamation mark inside it. And we can take slices of strings, just like we can of lists and tuples. Here we're going to start at 0, we're going to go to the end of the string, and we're going to get every second element. So it starts here at I, and then it hops over and it goes to this one. Remember, there's a character here and a character here, and because we're using exclaim, there's an exclamation mark at the end, and it's going to hop over this one and get that one, then it's going to hop over, and then it hits the end of the list, and it's like, I'm done. So once we have that, what characters did we get? We got the I, we got the heart, we got the snake. And so if we take a slice of that, we get I, heart, snake with no spaces. And again, just because there's no spaces in there, just because each of these are single character things in here, okay? It's not like this slice is going to take out spaces. It doesn't take out spaces. It just gets every other character starting with the first one. We can test if a letter is in a string using the in operator, just like we can with tuples and lists. We can say, is snake in the message? The answer is true. Is the letter A in the message? That answer is false. We can test if a substring is in there. Is the word the in this message here? 'Twas the winter of our discontent. Is that inside there? The answer is yes, so it will return true. So we can use the in operator just like we can with lists and tuples. Strings also have these methods on them that allow us to test the stuff inside of strings. So it'll look at the string and dot is digit will return true if every value inside that string is a digit. Is alpha checks to see whether or not everything inside the string is either is a letter of some kind. And so it looks at this first one and it's like, oh, that's an apostrophe. That's not a letter, so this is going to be false. And then in this case, is lower looks and checks to see is every single thing in here a lower character, and it ignores the white space for us. So is lower, that gets returned true. That's pretty cool. I'm not a big fan of these kinds of slides. All of this is in the textbook, but is alnum checks for alphabet letters and numbers. Alpha is just letters. Digits is just digits. Lower is all lowercase. Whether or not everything in it is spaces. Is upper checks for the is upper. Starts with checks if a string starts with another string. Ends with tests if it ends with another string. I mean, they're named pretty nicely for you to kind of remember what they are. This is the list. If you forget about them, look in the textbook. We also have some methods on strings that will then that will create a new string. Remember, strings are immutable. They're just like tuples. So if we do something with them, we create a new string. So we can call dot lower on a string and it will return a new string that has a copy of the old string, but all of the letters are now lowercase. And we can strip the white space from the left. We can strip the right space from the right. We can strip the white space from the left and right. We can change everything to upper, and then we can replace letters or substrings inside that string with other strings. So again, all of these are in the textbook. Feel free to read those and look at those examples there. I'm not going to go through them in this. We will see undoubtedly examples of this in the problem walkthroughs. A really important thing that we can do with strings is split them and then join them back together. And what that does is it allows us to do something cool with the letters inside the string and sort of ignore the spaces. So in this case, let's say we have this sentence, Hi, Noor Ahmadi. In Python, if we call dot split, this returns a list of everything that's been split on the white spaces like this. So we end up with a list that has three things in it: the word hi, the word Noor, and the word Ahmadi. And then once we have this list, we can loop over it. And for example, here we're changing each word to its uppercase value and then appending that, putting it in this upwards list. And then down here, we take this upwards list right here, this which now has an uppercase of Hi and Noor and Ahmadi, and we join them together, each of those entries, with a space. That means put a space between all of them. And that creates one single string that has all of those uppercase letters in it because we put the uppercase here. So join, split takes a string and splits it on the white space and gives us the individual words. And then the join will take a list or a tuple of those strings and then combine them back together and put whatever is in here in between them. And that's how we can join it back into an individual string. This thing right here, splitting and joining strings, we do it a lot when we're interested in like looking at what's inside a string like this. So pay attention to this. We want to split it into a list, and then we take a list and we join it back up with stuff in between it. So in summary, strings are immutable sequences of characters, like a tuple is an immutable sequence of values. Strings are iterable, so you can loop over them. So you can loop over strings, you can test if a string is in another string, you can get their length, you can concatenate them together to make new strings, you can slice strings to get a portion of them, you can split strings to break them up into a list, you can test whether or not something is in a string, and then you can modify those strings. And when I say modify, that actually means you can create new strings. You can create new strings from old strings with things like dot upper, which will then take a whatever, like here's word dot upper. If word has a string in it and I call dot upper, that's going to return a new value that has that string with all uppercase letters in it. That's strings and text processing.